Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the Telangana SET exam 2024, that is TG SET 2024. In this video, we discuss the solutions of two problems from the section Algebra. The first question is on congruences, and it is at the serial number 78 in the above question paper. The second question is related to the degree of the splitting field, and it is placed at serial number 75 in the above paper. And both the concepts, congruences and the degree of the splitting fields, are very important for all the competitive examinations, including CSIR NET. These two questions are suitable for all these examinations. Right. This is the question number 78 from the section Algebra related to congruences. The given question is the units digit in the decimal expansion of 17 to the power of 17 to the power of 17 is, we are given four options. Let's now discuss the solution of the problem in detail. We have to find the units digit, that is the digit that is there in the units place, of 17 to the power of 17 to the power of 17. Right. Now, here the base is 17. The exponent is 17 to the power of 17. Make an observation. The power of 17 and study the digit in the units place in the power of 17. First, 17 to the power of 1. The units digit is 7. 17 square. The units digit is 9. Simply do 7 sevens are 49 and 9. 17 cube. 7 nines are 63, 3. 17 to the power of 4. 7 threes are 21, 1. From there onwards, these units digit will be get repeated. So, observe that the units digit form a cycle 7931 of length 4. Agreed. Now, 17 is congruent to 1 mod 4. Why? 17 by 4 divides 17 minus 1, that is 16. 4 divides 16. So 17 is congruent to 1 mod 4. You recall a result on congruences. If A is congruent to B mod M, then A power K is congruent to B power K modulo M for any positive integer K. So from this, apply here. This will imply 17 to the power of 17 is congruent to 1 to the power of 17. K is 17. 17 is congruent to 1. 17 to the power of 17 is congruent to 1 power 17. But 1 power 17 is 1 modulo 4. Modulo 4. So that means, this means 17 to the power of 17 is of the form 4q plus 1. 17 to the power of 17 is congruent to 1 mod 4 means if you divide 17 to the power of 17, you will get a remainder 1. That is 4 times q plus 1. Agreed. Agreed. Now take 17 to the power of 17 to the power of 17 is equal to, the base is 17 to the power of 17 to the power of 17 is of the form 4q plus 1. Now remember here 17, the units digit form a cycle of 7931 of length 4. For every 4 it repeats, it gets repeats. So what will the units place in 17 to the power of 4q plus 1? It is same as the units place of 17. So the units digit of 17 to the power of 17, 17 to the power of 17 to the power of 17 is the units digit of 17 to the power of 4q plus 1. So this is the units digit of 17 to the power of 1. That is 7. That is 7. So the answer to this question is option 1. So our answer 7 appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of the given problem on congruences. So this question tells you that you have to study the congruences and their properties. They are very, very important for working out the problems. Right. We move to the next question. Right. It is the question number 75 from algebra. It is about the degree of the splitting field. Right. It is from the subsection extension of fields. Now the given question is the degree of the splitting field of the polynomial f of x is equal to x to the power of 4 minus 2 over the field of rational numbers, that is q. We are given 4 options. Options are here. Agreed. Agreed. Let's now discuss the solution of the problem in detail. We are given the function or the polynomial f of x is equal to x to the power of 4 minus 2. Now, what are the roots of this polynomial? So, x to the power of 4 minus 2. We are just computing the roots, all the roots we require for the splitting fields. X is equal to 2 to the power of 1 by 4, the real value of 2 to the power of 1 by 4 into 1 to the power of 1 by 4. That is the fourth roots of unity. That is 2 to the power of 1 by 4 is fourth root of 2 into the fourth roots of unity are 1 minus 1 I minus I. Therefore, the roots are the fourth root of 2 minus the fourth root of 2 comma I times fourth root of 2 minus I times fourth root of 2. These are the 4 roots. Where are they? Are they in Q? Is it there? Is fourth root of 2 is there in Q? No. What about the remaining? No, they are not there. So you have to find out the splitting field. What is a splitting field? The splitting field of fx over q, the field of rational number, is the smallest field extension that contains q and all the roots of fx. So you have to look for extension of q in which all these roots exist, and that will be the smallest extension. Then you find out the degree of that smallest field extension. Thus, the splitting field must contain fourth root of 2 and I. That means you have to look for that extension in which the fourth root of 2 is there and I is there. And that will be you have to find that smallest field in which these two are present. First, let us look at Q. In Q, do we have the fourth root of 2? No. Then make an extension. That extension is Q fourth root of 2. And what will be the degree of this extension over Q? For that, you have to look for the minimal polynomial related to the fourth root of 2 over Q. The minimal polynomial, that means a polynomial whose degree is minimal, satisfying this one. And it's a monic polynomial. It's a monic polynomial. That is x to the power of 4 minus 2. Now, is it irreducible over Q? Yes, it is irreducible over Q. We have done the same problem quite a good number of times using Eisenstein's criteria, in which you have to take P is equal to 2. This I am leaving it to you as a homework. That is, x to the power of 4 minus 2 is irreducible over Q by Eisenstein's criteria with P is equal to 2. So that will be the smallest field extension in which fourth root of 2 is present, and hence the degree of Q fourth root of 2 over Q is the degree of the polynomial, minimal polynomial. What is the degree? 4. It is 4. So the degree of this field extension Q fourth root of 2 over Q is 4. Right. That means we got now in Q, we got now fourth root of 2 and minus fourth root of 2. Do we have in this Q fourth root of 2, do we have I, the imaginary unit? No, we don't have. Therefore, we require to extend this field further. So degree of the, so what we do? We annex to this Q fourth root of 2, we annex, that means make an extension by adding the I, the imaginary unit. So we have to find out the degree of Q fourth root of 2, and we are extending by adding I over Q fourth root of 2. So from this base field, we are adding I, extension. For that, we have to find out the minimal polynomial for I over Q fourth root of 2. But before that, we take the minimal polynomial of this I over Q. That is x square plus 1, we all know. Now we ask the question, is I present in Q fourth root of 2? No, I is not there. Therefore, it will be an irreducible polynomial over Q fourth root of 2. We are not finding its roots in this. Hence, the degree of this extension Q fourth root of 2 I over Q fourth root of 2 is the degree of the minimal polynomial. That is minimal polynomial x square plus 1. The degree is 2. Now use this formula. This is sometimes called the towering formula for fields. Some people call it. The splitting field of f of x, that is x to the power of 4 minus 2 over Q, is this extension, that is Q fourth root of 2 and I. Now look into this field extension. In this field extension, all the 4 roots are present, and this is the smallest extension. So the splitting field will be Q fourth root of 2 comma I. So the degree of Q fourth root of 2 comma I over Q is equal to, first over Q fourth root of 2, then multiplied by Q fourth root of 2 over Q. Right? This is a very well known result. And for the first one, the degree of Q of fourth root of 2 comma I over Q fourth root of 2 is 4, multiplied by the degree of Q fourth root of 2 over Q is 2. So the answer is 2 into 4, that is equal to 8. that is equal to 8. So the degree of the splitting field of f of x is equal to x to the power of 4 minus 2 over q, the degree is 8. Where is 8? Option 3. So the answer to this question is option 3. That is the detailed discussion of the solution of the problem related to degree of splitting fields. And it is one of the most favorite example for the examiners. Many a times they ask, what is the splitting field? Or else, what is the degree of the splitting field? So these are, that's a very important and a favorite topic for the examiners. So go to the field theory, study extension of fields and what are splitting fields and the degree of the splitting fields. Various examples you have to try. First learn the concepts, then work out so many problems. Take the previous year questions. And this question is suitable for the CSIR net also. Very much suitable for this CSIR net. Right. I am sure that you understood the solution of these two problems from the section algebra. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member. You have to join as a member, not the question of subscribing. You have to join as a member in my channel and support me and my channel. Please subscribe my channel if you are not already subscribed to it. Yes, I will meet you all once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.